today is focus, well, this part of the chapter is called Focus on a Parabola. Focus on a parabola. And what we're doing today, tomorrow, and Friday is all going to be focused on this one thing here. Okay? It's all going to be focused on this focus on a parabola. And one of the biggest things I will say with this part here, this 2.3 that we're going to cover, this here, is really pay attention to the equations. You can already see them there on your note sheet. Those equations there will have another set of 2 coming tomorrow, but they're the exact same thing. It's only one minor change. Okay? So the ones we use tomorrow will work with any of them. These here are specific case, and I'll point it out when we look at it. But really pay attention to these equations, because it's really matching up what do they give us, what's the equation, and using those in combination. Because if we can use those in combination, these are going to be easy. Okay? Because once we see that connection of how they work together, the information in the equation, it's really looking and identifying what matches with what. Okay? So let's look at the equations here. So previously you learned about quadratic functions. All sets of points are equal distance from a fixed point called the focus and a fixed line called the directrix. So we have this here. Now they go through the explanation of how they go through and find the equation. And I'm not going to cover that because I find it to be more confusing when we look at that and look at it that way and how they equate everything. So we're not going to see that. I'm not going to show you that because it's more confusing than it's worth. But as you see here, we have 2 equations, yes? One is y equals 1 over 4p x squared. One of our equations is y equals 1 over 4p x squared. Y'all see that there, yes? That's our first equation. Now the focus is 0, comma p. Focus is 0, comma p. Well, where's the p value in our equation? 1 over 4p, yes? So the number in front of x squared for this equation is where our 1 over 4p is, okay? So again, when I talked about earlier, connection, we need to see those connections. And we'll work through them and I'll show them and point them out. But making sure to see that. The directrix, y equals negative p. CTRA. Y equals negative p. Y equals negative p. And we have our graphs, okay? And when we look at this here, it'll help us determine which way it's going. So p is greater than 0, it's going to open up. P is less than 0, it's going to open down. And again, when you take the test and do this on the homework, you can reference these here and look at these here. P is greater than 0, it's up. P is less than 0, it's down. Now our other one is x equals 1 over 4p. Y squared. Our focus is p, comma, 0. Our directrix is x is equal to negative p. P is greater than 0, it's to the right. P is less than 0, it opens to the left. And we have this here, and we see it's really all of these equations and how we interpret them and look at them is based off of p, isn't it? Because that's where all the information comes from. Now we have this here, and okay. Horizontal and vertical, or so for y equals, when y is not the one with the power, x is to the second power, the axis of symmetry is x equals 0. This one, y equals 0, okay? And for the ones we look at today, that's not going to change, and the vertex will always be 0, 0. So for the 2 we're doing today, the vertex will always be 0, 0. And the axis of symmetry, the vertical axis of symmetry for when x squared is y equals 0. or x equals 0, and horizontal is y equals 0. Those don't change. So this is our first problem. Let's look at it. So we're going to look at this first problem here. We're going to identify the focus, directrix, and axis of symmetry. And then it says graph. Now, we're not going to physically graph it because it's going to require having some points. But having the focus, directrix, and axis of symmetry will give you enough information to pick, because again, it's going to make you pick between one of the four graphs, if you've noticed that by now, of what we're going to have. And the information we get here will give us that information to pick which one's the correct graph, okay? So the first thing, so what we want to identify is focus, directrix, and axis of symmetry. So looking at this here, and looking at kind of our equations, is this graph going to open up or down, left or right? Because it's either going to open up, down, left, or right. And the way that I know which one I'm working with and how it's going to open is based off the equation. It's based off this equation. And when I look at this equation, my first thing, especially for 2.3, all we're going to cover this rest of this week, is based off this equation here. What variable is squared? What variable is to the second power? Y is to the second power. So what I do, as soon as I see that y is to the second power, I go back to my equations and look and see which one's to the second power. The one in red, the one I wrote on the whiteboard in red. The one that has y squared, yes? That's the first thing I look at and see which one does this match up to. I have y squared. Okay, so I'm looking at the equations and all the information that's dealing with the one with y squared. Now, when we look at the general equation says x is equal to 1 over 4p y squared. Now, don't get so caught up on how that equation looks. There's one main thing that we need to see. The variable that is not squared is by itself. Yes? And both of these here. The variable that's not squared is by itself in both general equations. Yes? This variable that is squared, that is to the second power, has other things with it. Yes? So that's the second thing we do. That's the second thing we do. Because this here, x equals 1 over 4p y squared, that's the equation we're working with and all the properties we're going to work with. The equation we have is negative 4x equals y squared, yes? Yes, it will be opening. Well, since it's negative, we'll deal with up, down, left, right here in a minute. Because it's y squared, when we look at those properties, the two options we have are left and right. So it's either going to open to the left or to the right. And I don't make any judgment or kind of any decisions about which way it'll open or the value of p yet. Because when I look at this here, we said we're going to have x by itself for this example, yes? Is x by itself? Well, no, we have negative 4x, yes? So our next thing we're going to do is we need to get the variable that doesn't have an exponent by itself. So looking at this here, what do I need to do to make? We're going to divide both sides by negative 4. And when I divide both sides by negative 4, well, those two simplify to 1, and I get x is equal to y squared over negative 4. Yes? Now, with all of these here, so, okay, before I move on, is x by itself? Is the variable without an exponent by itself? Yes, that's what we did, yes? We got that. Now, I'm going to rewrite this is equal to, so we have negative 1/4 y squared. I'm going to move the variable outside that fraction. Are we comfortable with that? Yes? Because negative 1/4 times y squared is the same as negative y squared over 4, yes? These two here are the same thing, yes? Now, I rewrite it as this here because we're in our next step, we're going to be comparing these two here. So far we figured out we're using x equals 1 over 4p y squared because the equation we were given has y squared, yes? So that was just looking at it, seeing, okay, y squared, this is what we're going to be using. These are the properties we're going to be using. Then we saw that x wasn't by itself. So we made it by itself, yes? And then we rewrote it in this form here. Now the reason I did that is these kind of match up now. Yes? We have x by itself here. I have x by itself here. Okay. We have a y squared, 1 over 4p, and we have a number here, yes? Because p, 4p, or p in the denominator there, is the only variable, yes? I mean, that's the only variable other than x and y. And that's our input-output for a function. Because our focus for this here is p comma 0. Our directrix is x equals negative p. And the axis of symmetry, y squared, horizontal axis of symmetry is y equals 0. So hey, we had axis of symmetry before we even started this problem, yes? Because y squared told us. Since y squared, this is what it is. So what am I missing here and here? I'm missing the value of p, yes? Okay? Four p, 1 over 4p times y squared, yes? What's in that same place? Negative 1/4. Yes? So to find the value of p, what I'm going to do is 1 over 4p is in the same place where negative 1/4 is, yes? I'm going to set them equal. Because if these two equations pretty much, they match up 100% the same, yes? X matches with x, y squared matches with y squared, so the 1 over 4p matches up, yes? For these two to be the same, that has to match up. So I can set them equal to each other to solve for the value of p. Solve for the value of p. Any questions on this here? Any questions on this here? Because this here is going to carry over throughout this entire 2.3. Are we good with this here? Yes? I'm going to multiply both sides by 4p. And the reason I'm multiplying both sides by 4p is I need that variable out of the denominator. Because 4p and 4p will cancel, leaving me with 1 equals negative 4p over 4. Well, actually, 4 divided by 4 is, so we have negative p. We have one last step. What do we need to do? We need to divide both sides by negative 1. Negative 1 is equal to, negative 1 is equal to p. I found the value of p. That's it. Questions on this here? Questions on how we found the value of p? So we good with this here? Yes? Okay. Means I can come back up here. So our focus is, and our directrix is, well, negative 1. negative, negative 1, because the directrix is told to us x is equal to negative p. And the value p is negative 1, yes? So it's negative, negative 1, but we don't really write negative, negative 1. We just write positive 1, because a negative and a negative make a positive, yes? That's it. That's it. That's all we have to do for this here. Now, there is the graphing the equation, and you'll have to graph on the homework assignment, quote unquote graph. Are y'all really graphing? No, you're picking which one's the correct graph, yes? Now, we said the value of p is negative 1, yes? Is that greater than 0 or less than 0? Negative is less than 0, isn't it? It's negative. So what does it say here? P is less than 0, it opens to the left, okay? So out of the 4 graphs, I have a feeling one of them at least is going to open left. One of them should open left. Focus and directrix. Line those up, okay? If you struggle with that, I can help you out, but really having the directrix and focus and knowing it opens left, locating those 4 points, and they will be labeled. They should be labeled on that graph. So we know it opens left. Looking to see if the focus is negative 1, 0. And the directrix is x equals 1. If those 4 things match up on the graph, or those 3 things, it opens left. It has a directrix of x equals 1 and a focus of negative 1, 0. That's the correct graph. Does that make sense? Yes? Okay, let's do another one. Identify the focus, directrix, and axis of symmetry of this here. Focus. Directrix, axis of symmetry. Now again, we have the equation negative 2x equals y squared. So what variable is being squared? The y value, yes? So that means I can look back at my equations and see, okay, so again, we're doing another one with y squared. So the focus is p comma 0. The directrix is x is equal to negative p. And the axis of symmetry is y equals 0. I'm 1/3 done. I haven't even done anything yet. All right? Axis of symmetry, y equals 0. We're 1/3 of the way done. Now we just need the focus and the directrix. And we get those from the fact that x is equal to 1 over 4p y squared. And what's our equation? Negative 2x equals y squared. So with these equations here, with the one we're working with here, which variable do we need to get by itself? We need to get x by itself, yes? So that it matches up with our original one. So we're going to divide both sides by negative 2 so that these 2's simplify and I get x by itself. And I have y squared over negative 2. We get y squared over negative 2. Now again, we can rewrite this, and I'm going to rewrite this so that I get x is equal to negative 1/2 times y squared. I move it off to the side because it's easier to work with. It's easier to match up what connects with p, what matches up with p. Because once we find that value of p, it'll tell us which way it opens. Because here, since y squared, it's either going to open to the right or to the left. It's going to open to the right if it's positive. And it's going to open to the left if the value of p is negative. It's going to open to the left if it's negative. And so what matched up to our 1 over 4p? The negative 1/2, yes? So what we can do is we can set it up as 1 over 4p equals negative 1/2. Now, for most of you looking at that, you're wondering, why couldn't we just set 4p equals negative 2 and solve, right? Because they're both in the bottom. I don't do that just in case we have a situation like this here. Where the numerator of the fraction we're pulling from the equation doesn't have 1 on top. Because if it doesn't have 1 on top, what this is implying is that the value of p is a fraction. The value of p is a fraction, and it can be a fraction. So that's the situation. We'll come across something like that eventually. So we're going to work it this way so that it covers every situation you can come across. Now, our first step is going to be to multiply both sides by 4p. Now, solving for the value of p, once we get it set up, our first step is always going to be to multiply both sides by 4p. When we solve this here, our first step will always be to multiply both sides by 4p. So here we get 1 equals negative 4p over 2. Because when we multiply fractions, we multiply top to top, bottom to bottom. And 4 just multiplies with the numerator, the top of the fraction. What's 4 divided by 2, or negative 4 divided by 2? It's 2, isn't it? 4 divided by 2 is 2, so we get negative 2p. Mm-hmm. We divide both sides by negative 2, and we get p is equal to negative 1/2. P is equal to negative 1/2. And we get this here. Yep. So since we have the value of p, we can come back up here and we can plug it in. So the value of p for this here is, so we have the focus be negative 1/2 comma 0. And our directrix is going to be negative 1/2, because it's x is equal to negative p. It would just be positive, because a negative and a negative will make a positive. Will make a positive. So now we've found the directrix and our focus and the axis of symmetry. We found everything we needed. Now you might be wondering, well, it's a fraction, isn't it? Why doesn't it give us a whole number? Because a number in a fraction should give us a whole number, right? What's our general equation? 4 times p? Well, 4 times 1/2 is 2, isn't it? So it does work out. But we have this here, and when we graph it, match these things up. Match these things up with the equation. Because the p is negative, it's going to open to the opens left. It opens to the left. Any questions on this here? Any questions on anything we've done so far? We good with this here? Okay. Focus. Directrix, axis of symmetry. So looking at our equation, which variable is being squared? Which variable? X. So since I see that x is being squared, I can reference back to my equations, and I'm going to be looking at y equals 1 over 4p x squared equals 1 over 4p x squared. Well, it also told us something. It told us the axis of symmetry is x is equal to 0. X is equal to 0. Yes. So far, just because the equation has x squared, it tells me that the axis of symmetry is x equals 0. It's just straight from the formulas. It's straight from our definitions. So now we're going to look at our equation, y equals 0.5 x squared. So we need y by itself. Do we have y by itself? Well, this one here, it already gave me in that form. I don't have to manipulate this equation at all to find the focus, which is going to be 0 comma p, or the directrix, which is y equals negative p. So we can go on and match it up. What are we matching up? 1 over 4p is going to equal what? 0.5. 1 over 4 equals 0.5. Now, you don't have to rewrite it as a fraction. You don't have to rewrite 0.5 as 1/2. We don't have to rewrite it as a fraction. We can leave it as this here. Now, what was our first step in solving for p? We multiply both sides by 4p. And we do this because the 4p and 4p will cancel out. They'll simplify out. Which leaves us with, what is 0.5 times 4? 2. It's the same as saying 1/2 times 4. Half of 4 is 2p. So we're almost done solving for p. We've got one more step. We're going to divide both sides by 2. Yep. So 1/2 is equal to p. 1/2 is equal to p. So we found the value of p, yes? So does that mean I know the focus and directrix? Yes. So I can go back up here. And the focus is going to be 0 comma 1/2. The directrix is y equals negative p, and p is and that's it. That's it. That's all we have to do for this here. Any questions on this here? Any questions on anything we've done so far here? We good with this here? Yes? All right, let's look at this one here. We need to find the focus. The directrix and axis of symmetry. So looking at this equation, what variable is squared? X. So that means our focus is 0 comma p. The directrix is y is equal to negative p. And our axis of symmetry is x is equal to 0. X is equal to 0. X is equal to 0. And the equation we're comparing this to is y is equal to 1 over 4p x squared. And the equation we're looking at is negative y equals x squared. So when we look at this here, is y by itself? Is y by itself? No. What is with y? negative 1. So we need to simplify that. How can I simplify that? We can divide both sides by negative 1, which tells me y is equal to negative x squared. So this one here was a little bit easier. It wasn't as easy as the last one to simplify or kind of get the variable by itself, the variable without an exponent by itself. I guess it already was on the last one. Here we had to divide by negative 1. And when we do that, we have it. Now what's matching up with 1 over 4p? What is going to match up with 1 over 4p? It would be negative 1. The squared is with x. We don't need the x squared because the 1 over 4p is not connected with x squared. It's multiplied by it. But the negative 1 is the only thing matching up with our 1 over 4p. Now we need to solve for the value p, and our first step is always the same. The first step we do is to multiply both sides by 4p. Because 4p and 4p will simplify, leaving me with 1 is equal to negative 4p, because negative 1 times 4p is just negative 4p. Last but not least, we need to get p by itself, so we're going to divide both sides by negative 4, which tells me negative 1/4 is equal to p. Any questions on how we did this here? Any questions on any of this here so far? So hopefully as you're noticing this here, it's really just matching things up. We need to get it to look like the equation, our general equation we start with, so y equals 1 over 4p times x squared, or x is equal to 1 over 4p y squared. We need one of those two. And once we find the value p, we plug it back in. So our focus is 0, comma, negative 1/4 for our value p. And the directrix would be y equals negative 1/4, which will just be positive 1/4. And the graph, we just match it up. We match up our information. And that's it. Questions on this here? Questions on anything we've done so far? Are we good with these here? We feel comfortable with these here? Okay. Last thing we're going to cover today is this here. This here, writing the equation of the parabola shown. Writing the equation of the parabola shown. Now it tells us that the vertex is 0, 0. This tells us nothing for these problems here, because all the ones we've dealt with so far have a vertex of 0, 0. But it's going which direction? It's opening down. Yes? It's opening down, isn't it? Well, it has to be a negative value p, but the only one that opens down, is y equals 1 over 4p x squared. Y equals 1 over 4p x squared is the only one that opens down. Yes? So let's look back at this here. Did they tell us the focus? Is there a focus labeled anywhere on this graph? No, but they did label the directrix, yes? And the directrix for this general equation here is y equals negative p. Yes? Well, what is this here? This is y equals positive 3, because it's crossing at the 3, yes? Y equals negative p. Well, we said what? P is 3. Well, it says y equals 3. Since p is being change the sign. So what we're saying is negative p equals 3, which means p is equal to negative 3, yes? Are we good with that? Are we tracking with that there? Yes? Plug it in. 4 times negative 3 x squared. What is 4 times negative 3? That's it. So we're either going to use the focus or the directrix to find the value of p, plug it in, simplify. Plug it in and simplify. And that's it. That's all we have to do for this here. Because as soon as we find the value of p, we plug it in, and we're done. For these here, we plug it in and we're done. We need to look at another one because it'd be helpful, yes? Very good. Directrix. Yeah, so here the directrix would be y equals negative p. Well, it tells us y is equal to negative 2.5. So from this here, the value of p is has it told us y equals 2.5? Our normal one is y equals negative p. Negative p, negative 2.5. So we have a negative in both, yes? So that means I'm not taking the negative, I'm just taking the number, 2.5. Now, which direction is it opening? Is it opening up or down? Up. This one here. But we also could have seen that the directrix was y equals, because it told us y equals negative 2.5. Well, the directrix for this one is, for one of them is x, the other is y. Since we had y, I'm going to use the x formula. Y equals 1 over 4p x squared. And we said the value of p is 2.5. So we plug it in. 4 times 2.5. We can type in the calculator 4 times 2.5, yes? We can do that? And 4 times 2.5 would be? 4 times 2 is 8. Yep. Questions on this here?
Actually, I got
10? Okay, yeah. Yes, it's 10. Because 4 times 2 would be 8, and half of 4 is 2. 8 and 2 is 10. So it works out it's 10. Y equals 1/10 x squared. That's it. Questions on this here? Any questions on this here? Let's look at this one here, number 6, the focus. It gave us the focus. Because this here, when it gives us the focus, it's actually easier than when they gave us the directrix. Write the equation of the parabola. So 0p or p0, what do we have? P0. So the equation I'm using is x equals 1 over 4p y squared, yes? Because that's the one that had a p value of the focus in the x spot, yes? P is negative 2. It just told us, yes? So x is equal to 1 over 4 times negative 2. And that's it. We plug it in. I mean, we didn't have to change the sign. We didn't have to worry about a sign change with the directrix. Here, it's just this is the value. This is what it is. And that's it. That's all we have to do is we get that value, plug it in, and we're done. questions on this here? So looking at this one here, if we plug it in, we get y equals 1 over 4 times 3/2 x squared 2, 6, and that'd be our answer. And I'm just rewriting that out so that you can have it there and kind of see it. It works the same way with either equation. When we're finding the equation, we just have to find the value of p and then plug it in. And that's all we're doing.